Now we're going to talk about turbomachinery, and this will be the last topic we have in this class. Turbomachinery is the practical side of fluid mechanics. These are the machines that either extract energy from a moving fluid or add energy to a moving fluid. And so for many of you as engineers, you won't be studying the details of complex fluid mechanics. You won't really need the Navier-Stokes equations. You'll be trying to size pumps or compressors or fans so that you provide the needed fluid flow, or you'll be extracting energy, working in the power industry. So this is the kind of thing that that applies if you're not exactly an expert in fluid mechanics, but if you're someone who just can be useful as a mechanical engineer to help someone design or select a proper pump. So here's some common examples of turbo machinery. So fancy word for something that you see all the time. Window fans, turbo machines. This is a very obviously the pressure of the fan, very low pressure increase, but you move the wind, you move the air, which adds energy to it. So you're going to add energy to it, you're going to increase its kinetic energy, and that's going to cool you off because it moves. Wind turbines are, of course, exactly the reverse. So wind turbines, the wind makes the turbine move, and the turbine extracts energy from the wind, and then it generates electricity. Windmills, of course, exactly the same thing, except they use the energy for a different purpose. In the case of a windmill, literally moving a grindstone so that it can grind and mill corn or flour, wheat. Well pumps, of course, anything where you're moving water from one place to the other is going to require a pump of some kind. Going to add energy to that flow to get it up a hill or through the friction resistance of the pipes. Bicycle pumps, all kinds of air pumps, whether you're pumping up your bicycle tires or your car tires, you're going to have to add energy to that flow, add energy to that air to get it inside a high pressure tire environment. And finally, for an example, propellers. So propellers add energy to the flow, thereby increasing the air's kinetic energy and then throwing it out behind so that the object moves forward. So either the propellers on an airplane move air rapidly behind, thereby thrusting the plane forward, or propellers on boats or submarines moving that water rapidly behind, adding energy to that flow so that the boat or the submarine is propelled forward. So, say turbo machinery is the fancy word for it, but it's something that you're very, very familiar with. You see all the time. Okay, generally speaking, devices that extract energy from fluid are called turbines. So, devices that extract energy from fluid are called turbines. So that's pretty much always the case, except for windmills. They're turbines. So you're going to see lots of different turbines. We know that they exist in lots of different places. As we've discussed, turbines are used to generate basically all the electricity that is used in the world. Almost all of it is generated by a turbine. It's generally generated by a steam turbine. So you heat up water, you actually compress it first, then you heat it up to steam, and then you blow it through a turbine, or actually often multiple turbines, and you generate electricity with that. So what you heat the water with varies a lot. So people use gas, they use coal, they use oil, they use nuclear fuel, geothermal sources. All of those things are ways to heat the water. But at the end of the day, almost all those technologies, they use that hot steam and blow it through a turbine to create the energy. So that's a huge area, obviously, of research, hugely important for our world that we generate all this electricity using turbines. The only example I could think of where you don't use, well, there are a few examples, but one that you see a lot of is photovoltaic solar. In that case, light is directly converted into electricity by semiconductors. The other type where you don't use steam would be actually something like a wave energy converter. But those are very, very small scale. No one's using those in a massive way as far as I know. So you've got turbines, very important field, particularly in the energy generation area. Oh, also dams. Hydraulic dams don't use steam, but they also use massive turbines. That's how they generate their electricity as well. All right, so if you're not talking about turbines, we have pumps. And so pumps add energy to fluid. So they're basically you can, use the overarching word pump for pretty much anything that adds energy to fluid. But in common parlance, you don't usually call everything a pump if it's working on a gas. So for gases, although they are in fact pumps technically, if you wanted to call them that, you could sort of stick to your guns and do it. Most people don't call things that are moving gases pumps. You can have the fans we already discussed. So types of for gases we have three different pumps. We have fans, and what characterizes a fan is very small pressure increase. So when it's just almost no pressure increase, you're really just moving the air without increasing its pressure. We call that a fan. So you know this when you turn on the fan in your house, the pressure isn't significantly different. The air just starts to move. If we have a larger pressure increase, for pressure increases up to 1 atmosphere of increased pressure, those are generally called blowers. So when you have something that's pushing harder, increasing that pressure more, up to 1 atmosphere, we call that a blower. And if you get past 1 atmosphere of increased pressure, obviously we're almost always at 1 atmosphere of the air we're dealing with, but if you increase the pressure by 1 atmosphere, that's when we start calling it a compressor. So all of these apply to all gases. So you can have fans that blow air, you can have blowers that blow air, but of course you can blow other gases. You can have fans that move other gases as well, and you can have compressors. Obviously, compressors are used a lot in refrigeration systems. So those are the three types of pumps that you use for gases. And say basically when it's liquids, they're pretty much always just called pumps. And there are different types of pumps, and we'll start talking about those different types of pumps. But basically, if you have gases, you might have fans, you might have blowers, you might have compressors. But if you have liquid as your fluid, then you're going to just call it a pump.